Hello. Now, my name is Oğuz Salar and this is my EEE 419 power electronics project. For this project, I designed the PCB for and then later fabricated a flyback converter that takes in 220 volts AC and turns it into 12 volts DC. As you can see, my error is close to nothing, which is less than the 5% specified in the assignment. As you can see on the oscilloscope, my peak-to-peak ripple is around 50 millivolts, which is also way less than the 200 millivolts specified in the assignment. In order to measure its efficiency, I connected it to the wall outlet with a power meter attached to it. As you can see, it's currently drawing 4 watts, and I have 12 volts on the output with a 50 ohms load. So this gives me an efficiency of around 72%. When the input is connected to an AC source, first then this AC voltage is rectified using a half-wave rectifier, which are done by this diode and this capacitor. Then this rectified AC voltage is fed into the transformer via the switching IC, which ensures that the output is a constant 12 volts, with its feedback mechanism. When the switch is on, the primary is shorted with the AC signal, so it charges up during the off-on period of the switch. And when the switch turns off, all this power is dumped into the secondary and tertiary sides of the transformer. The tertiary side is for the feedback system, which, as I said before, which ensures that the output is a constant 12 volts. It does it by making sure that the feedback pin of the switch has a constant 1.67 volts, which is voltage divider. As secondary and tertiary sides have the same turns ratios, the voltages are the same on both sides. On the secondary side of the transformer, there are smoothing capacitors that make sure the voltage is closer to DC. And there are 2 Zener diodes in series that make sure the voltage doesn't exceed 13 volts DC. In order to do this, I used 5.1 volts and 8.2 volts Zener diodes. I also added an LED on the output to make sure that I know when it's working. And after all these processes, when I input an AC voltage, I get a constant 12 volts DC voltage from this connector. There is also the snubber network, which takes care of the excess power when the switch is turned off. After completing all the steps of this project, starting from the design of the flyback converter, simulating this design, designing its PCB, and then later fabricating it, I was able to understand how flyback converter works even better. I was able to learn how a PCB is designed. So I believe this course and this project has made me learn a lot of things. So I'd like to thank Professor Abdullah Talar for this course, and I'd like to thank you for watching my presentation.